Hi, in this video we are going to discuss about linear regression. So when we are discussing about linear regression, the first term that we deal with is correlation. So what actually is correlation? Correlation basically defines how two features are related with each other. Okay, so if there are two features x and y, and by increasing one feature other feature is increasing, then we say that they have a positive correlation. For example, memory consumed versus number of users. So if a number of users are increasing in a platform, then the memory consumed will also increase. And the negative correlation is when decrease in one feature increases the other. For example, exercise and weight. So if you increase the exercise, then it is very likely that your weight will decrease. And the third type of correlation is that there is no correlation. So there is no effect when we change one feature. There is no effect in the other. For example, the shoe size and IQ. Okay. The thing about correlation is that the value of correlation lies between -1 to 1, and -1 means that it is a perfect negative correlation, and +1 means that it is a perfect positive correlation. Now, what are outliers? Outliers are basically points which are very different from the entire data set. Okay, so as you can see, this is one of the linear regression model, and all the points are lying in this particular region, but outliers are the points which are lying in a different region themselves. Now if we have to take an example for outliers, is consider a hostel student who is living in hostels basically, and on daily basis the transactions in his bank account are about from 0 to 500 rupees. Okay, so this is the daily amount that he is spending. Now suddenly one day there is a transaction of 50,000 rupees in his account, his or her account. So that is a possible outlier. That is definitely a outlier, and that is a possible fraud. Okay, so basically we use outliers for fraud detection, and a lot of applications we have for outliers. We will discuss about them in later videos. Yeah. Now, what are different types of regressions and what are their equations? In general, on surface level, we have three types of regression. First, we have simple regression, then we have multiple linear regression, then we have polynomial linear regression. All right. So when we are talking about simple linear regression, then we are talking about just one feature, as I've written here, just one feature and one target variable. So there is one x and one y. And the equation for simple linear regression is very similar to the equation of two variables. If you remember in your class 10th or 11th, there was a linear equation in two variables, right? So the equation was something like this, the intercept form. So y is equals to mx plus c, where m used to represent the slope of the line and c used to represent the y-intercept, right? So the equation is very similar to this format. The equation is y is equals to b0 plus b1 x1, where x1 is the feature and b0 and b1 are the coefficients. Okay, and as I just said, b1 is the slope. If you compare it with y is equals to c plus mx, then b1 is the slope and 0 is y-intercept, to be precise. All right. Okay, now we are talking about linear regression in multiple linear regression. Now in multiple linear regression, as the name suggests, we are having multiple features. Okay, we don't have just one feature, we are having multiple features. And what we do here is we just simply add a b1 x1 b2 x2, and all the features are added in a very simple manner. Okay, the third type of linear regression we have is polynomial, where we are not talking about different features, but we are talking about the different powers we have on the features. So you can see there is b0 where there is no feature, then we have a linear, then we have quadratic, and go on, as we go on we have n terms, so till the power of n. Okay, so this particular regression model is not linear, as it is very much clear. So regression is nothing but relationship between dependent and independent variables. So if we look at our equations, then the x type of characters that we are having, they are independent, and y, since it is the other side of the equation, it is the dependent feature here, dependent variable. Now the thing is that all the linear equations that we have studied, linear regression and their equations that we have seen so far, they are very ideal cases. We have not considered error till now. In the real life, when we talk about the linear regression, we also have to deal with some error. Okay, so the thing is, for example, if we are considering this particular graph, the linear regression equation is going to give you this yellow line. Okay, if you are talking about this graph, the linear regression equation is going to give you this particular yellow line. Okay, but the points are separated very far away. As you can see, the points are far away from the line, so this distance is what we call as error. Okay, so if we come to the real life linear regression equation, so in the equation itself, we also have to add a variable which represents the error. Okay, we also have to add this particular variable which represents the error of a particular model. And as you can see, this is the line from this particular equation, but we also have some errors. Yeah, so this was about real life linear regression equations. Then we have R squared values. What is R squared values? R squared value is basically R squared values is basically a measure of all the errors. Okay, all the errors ka aggregate. Okay, so in when we are calculating the R squared value, we are basically taking the aggregate of all the errors, and then we compute this particular value. The range of this R square value lies between 0 to 1, and the bigger R square is, the closer this R square value is to 1, the better is your model. Okay, so this was about R squared value. Another thing that we have here is spurious correlation. What is spurious correlation? Now, spurious correlation is the other word for spurious correlation is coincidence. Okay, so basically, when we have two things, logically they do not they should not have any relation. Okay, when we are talking about two things, logically there is no relation, but when we are plotting their graphs, they seem to have some relation. Okay, so that is spurious correlation. So when two things logically don't have anything in correlation, but their graphs seem to correlate. Statistically, if we talk, there is correlation, but there isn't any. It's just a coincidence. And now here we have a graph representing a spurious correlation. So the graph is between worldwide non-commercial space launches and the sociology doctorates awarded in US. And as you can see, the graph of both models is very similar, but very logically there is no relation between the both, so hence it is a spurious correlation. So in this video we just talked about linear regressions and a lot of points regarding that. In the next video we are going to take some of the points from this particular topic.